India, the world's 9th largest economy, a nation on the fast track to economic growth, a nation with a rich history and vibrant culture, but yet a nation that continues to battle formidable challenges. Pollution, poverty, growing population, lack of sanitary facilities, and inaccessibility to hygiene standards. With water supply and sanitation in India continuing to be enormously inadequate, wastewater management has become the single most important focal point that needs immediate redressal. It has been reported that only 27% of the wastewater ensuing from sewerage is being treated in India. The rest is just being released into the environment, resulting in contamination of rivers and other sources of drinking water. Contamination by solid waste is the main cause for the spread of waterborne diseases like cholera, typhoid, paratyphoid, dysentery, and diarrhea. More than 80% of domestic water consumed makes into wastewater and is being disposed of. Water conservation and recycling become as important as solid waste removal from the environment. The Government of India has been searching for solutions for effective wastewater treatment. DRDO labs' painstaking research efforts in this field have borne fruit with the development of the biodigester. Biodigester made of FRP or mild steel is equipped with an inlet pipe for human waste. The inoculum of anaerobic bacteria helps convert the solid waste into biogas that is let off into the atmosphere and liquid effluent which can be drained off onto any surface and used for irrigation. This eco-friendly technology has several advantages over aerobic treatments such as no requirement of external energy, needs low nutrient, can withstand high loading rate with very low sludge generation. A large number of biodigesters have been installed at high altitude locations of army units, as well as in civil locations of planes. Indian Railways have also adapted this technology by fitting biodigesters onto train coaches. Septic tank. Septic tank is the most acceptable technology for wastewater management where sewage systems are not available. Size of a septic tank for a small family varies from 4 to 10 cubic meters, and large volume tanks are preferred to obviate frequent cleaning of the tank. This amounts to higher initial cost and space requirements, besides the foul smell of the effluent. P-trap is provided in the toilet to prevent foul smell of the septic tank in the toilet seat. To overcome the problems of conventional septic tank, DRL Tezpur has developed BioTank. The BioTank has several advantages over the conventional septic tank system. The size of the BioTank is approximately 1/3 of conventional septic tank, and hence material cost and space requirement for building the tank is lower. There is no need to evacuate the tank, which is required for conventional septic tank at frequent intervals. This tank requires no maintenance and very little quantity of H2S is produced as compared to septic tank. P-trap can also be avoided, thus reducing the amount of water usually used in the conventional system. The biotank resembles a trench dug in the ground to about 1 to 2 meters depth and connected to sewage through an inlet pipe. A trench of size 1 cubic meter is sufficient to handle waste matter generated by 4 to 10 people. The inner walls of the biotank are of cement or brick with a thickness of about 9 to 10 inches. Another wall of about 5 inches thickness is present in the center of the biotank. An inlet pipe for the waste is present that connects the toilet to the tank. Its other end is 20 centimeters above the base of the tank. The outlet pipe for carrying the effluent is placed on the other side. Above the center wall rests several aluminium and metal rods running parallel, and suspended from these rods are the PVC immobilization matrices that act as bacterial reservoirs, entrapping the bacteria after the first seed inoculum is introduced. The first seed inoculum of anaerobic bacteria is now introduced into the tank. These matrices act as the bacterial attachment sites within the tank and ensure the bacterial population in the biotank is always maintained at the optimum level despite changes in pH and excessive flushing. Routine and popular toilet cleaning agents can also be employed without affecting the bacterial population. Sewage enters the biotank through the inlet pipe. It then passes over the consortium of anaerobic bacteria that break it down into gas and effluent. The treated effluent comes out through the outlet pipe and can be used as such for gardening purposes, or can be treated further by passing it over the reed bed system. Biotank, an eco-friendly method for wastewater treatment, beneficial to environment as well as mankind.